We start our discussion of work using an example you are all familiar with. That is the work associated with the gravitational force when you raise or lower a mass through a height h. In SI units, the force of gravity, or the weight, expressed in Newton, is the product of the mass, m, in kilogram, by the acceleration of gravity, g, in meter per second square. The work is then the dot product of the force by the displacement, delta h. The magnitude of the work is then equal to the product m, g, delta h. Let us calculate, for instance, the work required for the lifting of 10 grams of nutrient to the top of a giant redwood tree of height delta h equals 368 feet and 7 inches. Using SI units, we obtain the magnitude of the work as 0.010 kilogram times 9.806 meter per second square times 368 plus 712 feet times 0.2967 meter per foot. Multiplying out, we obtain the result in the SI unit of joule, or W equals 11 joules. Consider now a gas contained in a cylinder of cross-sectional area A that is sealed from the surroundings by a piston shown on the figure as the red disk. Let us assume that during the expansion of the gas, the external pressure acting on the gas is constant. In the example showed, the external pressure acting on the gas is the sum of the atmospheric pressure and the pressure due to the weight of the piston. The magnitude of the work of expansion is written as the product of the force opposing the displacement of the piston by the displacement, denoted here by the symbol h. The force opposing the motion of the piston is the product of the external pressure by the area on which the pressure is acting. That is A, the cross-sectional area of the piston. So the magnitude of the work is written as W parenthesis equals H times A times P external. Then you should note that the product of H by A is actually equal to the volume traveled by the piston during the expansion. This volume is also the change in the volume of the gas during the expansion. So we can express the expansion work as W equals P external times delta V equals P external times final volume minus initial volume. Now we need to address the issue of sign for this work. To do so, we use the sign convention introduced in the preceding lecture. A work done by the system on the surrounding is negative, and a work done by the surroundings on the system is positive. In the present case of an expansion, the work is obviously done by the system as it is pushing the piston upward into the surroundings. So the work of expansion must be negative. We observe that the change in volume during the expansion process, delta V, equals V final minus V initial, is positive, and the pressure is positive. So the work must be written as W equals minus P external times delta V. You will need to memorize this equation for the work of compression or expansion of any substance under a constant external pressure. Note that the equation is the same whether we are considering a compression, volume decreasing, or delta V negative, hence positive work, or expansion, volume increasing, delta V positive, hence negative work. The work is the product of a pressure expressed in the SI unit of pascals with symbol PA by a change in volume expressed in the SI unit of cubic meter. The product of two SI units is an SI unit. So the work is expressed in joule only when the pressure is expressed in Pascal and the volumes are expressed in cubic meter.